Hello everyone. This video is going to show how to program your VexCortex microcontroller so that it responds to tank tracks using the Wi-Fi control, or better known as the controller. First we're going to start is you need to make sure the EasyC is running, and I know from previous lessons, if you're listening to this December 17th or after and you're in my class, you probably saw that we made these programs together. This video is just going to serve as a purpose for saving the process, and if anyone has any trouble they can kind of refer to this as a reference. So first we're going to start a new standalone program, and just like I explained in earlier lessons, we are going to choose Joystick project even if we decide in the future to do autonomous. The reason why is when we debug and test, we don't want our robot to instantly run autonomously because it could theoretically drive off the table and break. So we're going to leave it as Joystick. We'll cause a button to start the autonomous mode in the future. So we're always going to choose Wi-Fi Joystick project and say OK. Okay. And at this point we're ready to program, but one thing I forgot to mention is make sure prior to us starting that you went and chose controller and you have VexCortex. If you have Vex IQ selected, that's more for Legos, and it's kind of what is done in the middle school. Okay, so anyway, with our controller set to VexCortex, we started a Wi-Fi controller type of program. At this point, what we need to do is create a loop that will continuously run and not shut off. So we're going to go down over on the left to our function blocks, and if you can't find these function blocks, let's say it's missing, it's gone. Okay, you're going to go to View, and if you take a look at project, functions, and so forth, you should be able to check these and have them show up. So let's go down to View. Okay, here's our Project Explorer, that was there before. View, right here, Functions block. Okay, another thing is if they are off floating in space, kind of like this, if you click and drag the ribbon, which is the area that has the title of the window, you'll see these little boxes pop up. If you put your cursor in any one of those boxes while holding down and dragging the window, you can dock them. So traditionally we dock it on the left. Okay. So as I said, we're going to kind of define a while loop, and while something equals something, and we're going to make this condition so that it never changes. It will continuously loop. Prior to looping, we have a couple things that we need in order to call upon them, and those things are called variables. Some of them will be constants and some of them will vary. Okay, so we're going to go over to globals, and we're going to double click. As you can see here, we have the top area that's specific for constants, and the name constant tells you that the value for that is never going to change. All right, so this is a great place to define what goes to what port in terms of hardware. So for example, we're going to put constants all in uppercase. We're going to type right motor with no spaces. We're going to go over to our value, and this is where you are basically wiring your motor. So for this example, we're going to choose 2. If your motor has the left motor hooked to 2, then obviously program accordingly. So we're going to go left motor. And for this project, we're going to choose motor ports 2 and 3. However, when you make your own custom robots, expand and scaffold up your knowledge and understand that you can change these to anything. Okay? You'll kind of start to see how these are being used at the moment in the next coming steps. So let's comment this out so we understand what this is. So we're just going to say, oops, motor port 2, motor port 3. These are constants. Now, for this current challenge, we're going to be adding a back bumper so that when the opponents tap the back bumper, it disrupts what you're currently doing. So it adds an element of play to the game. Not only are you concerned about scoring various objects within goals, you're also trying to defensively protect your back bumper so that you aren't disrupted in scoring. So let's call this back bumper, all in uppercase, we're going to put this on, we're going to give it the value of 1, and this is going to imply digital port 1, if I can type. Okay, these actually don't do anything unless we use them. But when I call the word or the variable right motor, left motor, or back bumper, it's going to instantly correlate these or link these to these numbers, which I can then use these numbers in place of actually typing the word 2 or the number 2 or 3 or 1. I just have to say right motor, left motor, back bumper, and it's already mapped to the proper value, which corresponds to the port that it's actually plugged into on the microcontroller. Now, that was definitely a big explanation right there. Listen to that again if you don't quite understand it. So we're going to drop this down. This is a global variable, meaning every part of the program, every function that we make, will be able to use this and see this number. It is a public number or a public piece of data per se, meaning anything in our program can see it. Okay? And you may have taken a class where you've learned about public and private. This relates to exactly that. So we have an int. This is going to be an integer type of variable. It is going to vary. That's why we're putting it down here and not up here. These constants do not vary. These vary, hence their name. So variables use a combination of lowercase or uppercase letters, or just all lowercase, but anytime you see anything in all uppercase, that number will not change, or it's intended to not change. Okay, our back bumper, we're going to give it a value of 0. This variable is actually going to keep track of if our button is pressed. Okay? So if you can see here, we're going to add a comment, and I'm going to tell you right now that 0 equals the bumper not being pressed. You need to know a little bit about how these bumpers report out signals, and now that you know, the programming will actually be pretty simple. But right now, you need to understand that if the bumper is not being pressed, it is a 0. Okay, so 0 equals bumper not being pressed. When it's pressed, it shoots out a 1. Okay, so at that point, what we are going to do is we are going to program in the tank controls right here. So we're going to drop down our joystick to 2-motor tank. And the reason why it's 2 motors is because you built your robot with 2 motors. It's not being controlled with 4. So we're going to take our 2-tank motor control and drop it right here. It's going to ask us questions. I explained this in previous lessons. You could have multiple joysticks controlling the same robot. And this is kind of where this is. So let's say your partner has a crane that needs to operate on the robot and you're responsible for driving. This is where you can say, okay, joystick 1 is maybe the motors that drive it, and then the next time you do it, it'd be joystick 2 could control like the crane. Okay, so we're going to leave it at joystick 1. Okay, left channel, right channel, as you can see, we can select these channels, okay, and these channels correspond to the controller. So if you're looking at your controller, which I'm running across the room now to grab, okay, the right-hand channel is 2, and the left-hand joystick is 3. So if you look at your controller, if you're holding it in your hands, the analog joysticks vertically go up and down, and they are defined as left analog up and down is 3, left channel, and then right channel is 2. So if you wanted to map this to different buttons, this is where it's done. Okay? Now, not to be confused with the 2s and 3s here for our right and left motor, they're entirely different things. It just happens to be the same number. So instead of using 2 or 3, we have these variables that we already defined. If you can remember the variables. Okay, the variables looked like this. Okay, we defined right motor and left motor. So all we have to do is call the names and it corresponds to the numbers. This makes things a little easier for you. Drop this down. Left motor should go to left motor. Right motor should go to right motor. Okay, now you have invert direction. So if you run this and your tank is going backwards instead of forwards when you push joysticks, both of them up, you'll come here and invert the direction. to 1. So this is one direction, and this is the other direction. So for now, we're going to leave them as default. We'll give it a comment. Tank track controls to motor. Like I said, this is just for people to read to help them understand what it is they're actually reading. So we're going to say OK, and now we have this. Okay, so we have tank to motor, and as you can see, my comment is in green. So this won't take too long to do the rest of the programming, but what we're going to do now is add in a couple conditions that will call another program that we're going to make, and that program is almost like a little program we can call multiple times. It's a multi-use, and that program is actually called a user function. So right here is our user function, and we're going to program a way so that the actual robot, when the bumper is touched, will be disabled and something will happen to it. So at this point, what we're going to do is we're going to right click, add a new function, and we're just going to call it StopTurn, kind of like this. Lowercase stop, uppercase T, and the rest of the letters to spell the word turn. You're going to leave everything else empty. We could leave a comment that says this function stops the robot and turns for a specified, I think I spelled that wrong. Just something that can better describe what this is. We're going to say OK. It says it right here. This function stops the robot and turns for a specified amount of time. All right. And we are going to build this function out in a different video, but we're going to leave it called StopTurn, and it will be loaded here. So we're going to close StopTurn. Okay, we're just going to pretend that StopTurn works. It's going to stop the robot. It's going to back up for a little bit, and it's going to turn the robot, and then it's going to stop being called, and then we're going to give you back the tank controls. All right, so at this point, we just have tank control being controlled by the joystick. Our StopTurn function is at least defined. If I double click it, there's nothing in it, but we can call it in a second. Okay, so we're going to need to make a while loop and put this inside it. Okay, so we're going to go down to program flow, or up to. You're going to find a while. So we're going to look for it, while loop. We're going to drag this in at the top. And you're going to say, we're going to need to make a condition that will not ever cease to stop being true. So 1 equals 1. So while 1 equals 1, we're going to continue to do something. 1's never going to not equal 1, so it's always going to run. Okay? So whatever we put in the middle here is going to repeat forever because of this. So we're going to take this guy and drag it into the middle. So while 1 equals 1, tank track controls will continue. Okay? So while that's going on, we can put an if statement inside this while loop. So while it is going on, we are checking to see if something is or isn't happening. And so what we want to know is, while the tank track controls are being used, is our bumper being pressed? And if our bumper is being pressed, we are going to call the StopTurn function that we have not actually fleshed out yet. We've defined the name of the function, but we've never actually programmed that out. But once again, I want to save this for a different video. And we're going to pretend, for the sake of this video, that StopTurn is fully defined, and we're going to call it. It's just not going to do anything if we run it. So while 1 equals 1, we need to check something. And what that is let's check to see if the bumper's being pressed. So we're going to go over to sensors in some way, shape, or form. Let's take a look. We have inputs. We have a bumper switch. We have lights, limits, potentiometers, opticals, ultrasonic for distances, accelerometer to sense motion, and so forth. I just want to make sure that I'm grabbing the right thing. So let's just open all these and take a look at them. Joystick obviously deals with motion. LCD, which we don't have. Battery. Some mathematic functions if you're trying to figure certain things out. Or need something calculated. Motor module, let's take a peek. No. No. Wait until. These might be useful. Wait until it sees something and then do something. Okay, but nope. That looks like we are going to grab just the bumper switch. We're going to drag it right into here. And the question is digital input. What input is our bumper going to be using? Here's where a variable that's considered a constant is useful. So I already mapped it to digital port 1 because back bumper just means the number 1. So by me choosing this is me basically typing in the number 1. The cool part is I can go up to globals later and change it if I need to change the wiring. The programming doesn't need to change because we are using a name to declare what port number this sensor is being hooked up to. Okay? So we are going to retrieve back bumper. Okay, so we have these two things. So if you notice, the back bumper all in uppercase that just means port 1 is retrieving a signal from bumper underscore back, which is the variable of 0. And once again, if 0 is there, it's not being pressed. And if it is being pressed, it's a 1. And I might, once again, let's say if bumper is equal to 0, meaning it's being pressed. Okay? So I'm sorry, I made a little bit of a mix-up in the beginning since this is a binary situation. By default, okay, if bumper back is equal to 0, it will be pressed. Okay? Meaning, by default, it's 1. Does that make sense? If it doesn't, it will in a second. Okay, so we're going to type a comment here that says, when bumper is not being pressed, its value is, we'll put in parentheses just so you can kind of have it numerically showing. Okay, we're going to say okay. So let's go back up to here. Let's go to our globals and see what we define this as. Okay, when bumper is not being pressed, it's a 1. Its initial state, okay, we have set the variable to be 0. Okay, so when it's being pressed, its value is 1. I'm sorry, not being pressed, it's 1. Okay, so this should work the way that it's been programmed. So we have while 1 equals 1, this just continuously is asking questions. Hey, bumper back, get the digital input from port 1 on the digital side of the controller and tell us what it is. When the bumper's not being pressed, it should be a 1. And if it equals 0, we need to, once again, stop and turn. Okay? So, we have this going on that automatically checks. That's all it's going to do. And it's going to make something equal its current state. Okay? Tank tracks are going to run continuously. And now we're going to put an if condition. Okay? What happens if this is a 1? What happens if it's a 0? So we're going to scroll up to the top. We're going to find our standard controls, probably program flow, if. We're going to put it right underneath here. It's still part of the while loop. We are continuously asking if. Okay? So we're going to say if bumper back equals 0. Okay? If it equals 0, we're going to do some stuff. So you're just going to say if bumper back is equal to 0, meaning it's being pressed. Meaning when it is being pressed, right, it is a 0. And when it's not being pressed, as you can see in my comment here, it is a 1. So we're going to say OK. So if bumper back is equal to 0, it means it's being pressed. Okay, we just have 1. So what do we want to do when it's being pressed? Well, we want to call that function StopTurn. So we just drag that out and put it here. And this function stops and turns the robot in an automatic way. Okay, so that's it. That's pretty much the program. The only thing is the stop turn behavior has not been defined, and we're going to kind of do that in a different video. So let's just quickly reiterate what we went over just to make sure that everything is clear. First, we went to globals and we defined some constants which automatically correlate easily understood words that you and I can create to harder to understand and remember numbers. So when I call right motor, I don't have to remember that it's a 2. I just call right motor. When I call left motor, I don't need to remember that it's a 3 because I can just call left motor. Same thing with back bumper. Now we have this integer style global variable that's called bumper back. Value is set to 0. Okay. And right now we have 0 equals bumper not being pressed. Let's make sure this is correct. So if bumper back is equal to 0, meaning it is pressed. So we're going to change this. 0 equals bumper being pressed. I want to make sure we don't contradict ourselves. It's very easy to do with a binary state because you can just flip your understanding and even subconsciously do that. So we're going to say OK. Okay. At that point, we have this where it's going to, the digital input, once again, this is just the word back bumper that implies digital port 1, as you can see the comment here. We're going to retrieve 2. We're going to get the digital bumper's state, which is going to be a 0 or a 1, and we're going to automatically retrieve it to bumper back. If it's 0, it's being pressed. If it's not being pressed, it's a 1. So right here is a comment when bumper is not being pressed, its value is 1. How do I know that? Because it says it right under help contents, and if I go over to search and type in bumper switch, if you take a look, it can distinguish between 2 states, whether it's pressed or not. When the switch is not pressed, the robot interprets this as a 1, and that is where I get that understanding. So this isn't something you could logically understand. You needed to know this. So we're going to close that, and currently, once again, it's going to stay at a certain state. When the bumper is pressed, this if condition will notice because of this statement, and then it will cause stop turn to execute, and currently it does nothing. So it's not going to do anything at this point. So right now, hit File, Save As, hit the little 3 dots, navigate to this PC, and find your last name. It should not say mine. It should be your network drive that is this map to letter G that has your last name. When you say OK, you're going to give it a name. I'm going to call this Stream Tank because I'm streaming this to capture it, and it's my tank controls. That's the only reason why I'm calling it that. You should just call it Tank. So I'm going to hit OK. Stream Tank is created. My program's ready to run. If I had the robot plugged in, USB to USB, you're going to hit Build and Download, and it should install. Okay. So at this point, you should have enough information to kind of get this primarily built out, and then we can kind of worry about the StopTurn function when we're done. Hope this wasn't too confusing, and hope I didn't contradict myself while explaining things too many times.